My name is Pablo Galindo.
And my name is Łukasz Langa.
And this is the core.py podcast, an established podcast where we discuss internals of CPython and our adventures in making a new version of your favorite programming language. Maybe someday we will choose a better word than established.
New. It's no longer new. Yeah.
Exactly. Yeah. How are you doing, Łukasz? How are you doing today?
Pretty good. I've heard that Karl Mayer's hockey team, the Bellingham High Sticks, ended the season in third place.
Third place, wow.
On the league table. There's 8 teams on that particular league. So they ended up being third by goal difference tiebreaker versus the team that ended second. So they will be playing next week against the 4th placed finishing team in a single playoff game for the 3rd place.
Wow.
So Karl is a little upset that they were literally 1 goal away from playing for first place. It only goes to show that Karl is always, having high expectations and delivering high value. So next year, I will not take anything else than first place.
All right. Go high sticks.
Go high sticks.
Yes, maybe if they win, they will give him a better mic. What about it? Okay, that's quite cool. We always love to talk with Karl. Maybe he can come to the show again to talk about UB and Astral and whatnot.
And the type checker that they were
writing.
Type
checker,
yeah.
Red Knot, I think it's called, right? Is that an official thing? I think it is.
I thought it was part of RAF, and I didn't really.
Yeah, but the tag that they use is Red Knot.
Oh yeah. There was this sort of code name for it. I think.
I mean, okay, but yes, that would be cool. Maybe we, okay, yeah, it's kind of CPython, right? Like PyPy, kind of.
It's typing in Python.
We can stretch it. Yes.
Right.
But today is different. We are not here to talk about sports, sadly.
Why not? No.
It's all CPython. That's what the podcast says. We are here to talk about me. That's the real deal. So Łukasz, just for everyone to know, Łukasz, as he's always thinking about our listeners, he wanted to talk about the GC. Everybody wants to know about the GC. It's the golden episode. Like, it's almost a meme now. But yes. I said, no, let's talk about me, Pablo Galindo. What else is to talk about than me? Because why I want to talk about me, Łukasz? What is the reason?
Because this is a demonstration how globally pausing garbage collection makes everything stop. So now everybody's going to have to wait until the next episode because you paused the world.
Oh, it's running on a different thread as well. Can't stop, won't stop.
Okay, so now we're starting a new thread. About what?
About my pep. Wow, my pep.
Your pep. Which one?
Man, I'm so bad by 768. I think so. Yes.
It's a really nice round number, actually.
Wait, why is round? Because it's even?
No, come on. 768 composes really nicely.
Okay. Kind of good mnemonic. Actually, I should learn this number. Okay. Yeah, that's kind of cool. Like it says, okay, 768. Okay, good. I like it. But what is about this? What this
pep is about formalizing some of the scariest experiences of my life with test external inspection.
Your real enemy, Łukasz. Why you don't like this external inspection?
Because there's just some how would you call them, spells in foreign languages that I don't understand there, but I just assume they do stuff and they actually work if you execute them. So I guess
that's interestingly
some ancient magic made it work, and I needed to make edits to those, so I did, and it does a little more than it used to before. But I'm not even sure how you started making that thing work. How you actually just realize, okay, this sort of thing is possible. We can actually poke at another process. But before we get to the weeds of this is scary and whatnot, people probably want to actually understand what is the PEP about, what's its name, what are you trying to do?
Right. So the PEP is actually about doing the impossible. The reason is because long ago when I started to code in Python, I really wanted to I came from C++, right, and C and compile languages, and those have GDB. It's a cool debugger, the GNU debugger. By the way, horrible code base, insanity is lurking there. Sorry, GDB maintainers, but it's true.
Because they didn't have a debugger to work with.
Right. You can attach GDB to GDB. Like it recognizes itself and activates a bunch of secret shit. Do you know that?
There's like an icon of a black hole.
Who debugs the debugger? So GDB can attach to processes, and that's kind of cool because you have something running over there, and then you say GDB minus P for process or PID. I don't know actually which one, but like you pass out the PID, a process identifier, and then you attach to the process, and then you can inspect live the process and stop it, and even poke at the memory of the process. You can even change it. It's kind of very cool. But I asked then why you cannot do it with Python, and what I was told, Łukasz, I was told that it's impossible, and that was not cool. I didn't like that, but I believe it. I say, okay, it's impossible, and that's what you are told when you're like small developer, small mind. And then I believe that, and for a long time I said like, yeah, it's impossible, and then I check, and actually I understood why it's impossible. Why? Because like actually GDB works in a weird kind of way. Like it's just fucking insane. Like if for instance, to modify the process, you actually need to compile assembly on the fly and inject the assembly through like some system calls, ptrace mainly, into the process. Like it's really complicated. It needs to deal with these symbols and shit. But like all the thing basically works because like it works on top of like the all this like basically foundation, which is like elf and like dwarf and all this crap. And this has been there for a long time just because every single compile process generates all this information that the debugger uses. By Python, it's not a compile process, so you cannot just use it. And like you're basically building on top of like so much stuff. But Python is like the matrix, right? Like it's really not like a program. Like the program is CPython, and then Python is just an illusion. It's like an illusion. There is no code anymore. It's just structures in memory. So you could use GDB, but it's useless because it only sees the guts of the interpreter, not really your code. What you want to see is the code, right? The data.
Exactly.
And that is really annoying. You can still do it. We ship with a bunch of like GDB helpers that many people don't know about, but they are very useful.
Yeah.
But that kind of like not really cool because like it's not a full debugger experience. It's really not great. So that's the reason it's impossible. But then very recently, as you mentioned, I discovered enough dark magic to basically make it work. So to make the impossible possible. Yes.
So that's one approach, but the other approach would be like the guy who discovered a new kind of hash table recently, right? Like there was this entire stir about how like now you can make really tiny pointers and so on and so on, and potentially we don't know yet, like maybe hash tables will be able to be much faster than we thought before. And the reason why the guy could make this performance improvement was that he didn't know about the state of the art that said that you cannot speed this up, so he did.
So that's the solution, not knowing that it's impossible. Okay. I like that. I didn't know about this the hash table thing, and now I'm very curious. But I will not stop this recording to look at it.
Oh yeah, and it's like okay, like let's not derail the discussion about debugging.
Right. Okay, but this is the holy kind of grail, right? Because it's not only about like the debugger things, like it's about changing a running process. Like people use GDB for this for like C and C++ and whatnot. Like but for Python, there is so many things. Like you can inspect what the fuck is doing. Like and like this is in many other languages. You were quite fan of this manhole thing, right? Like in what language was this?
That was in Twisted.
Oh, it's actually Python Twisted. Yes. So what does this do?
Well, this allows you to just look inside the running event loop and kind of figure out who waits on whom and so on.
Kind of inspect the program from outside and like look at it. Right. So
yeah, that's why it's called manhole.
Right. So then some people will say, but Pablo, like wait a second. You're kind of lying because like I use VS Code or whatever thing, and VS Code can attach to a running process. Like this is already there, and it's kind of like what is going on. And Membre actually, a program that you did, Membre today. So Membre like also does this shit. So like then it's kind of really it's really possible. But no, and now I'm here to discover
the evil secrets
of how those things work. Is really bad. Do you know how those things work, Łukasz? It's really bad. Disgusting.
If this is anything like the test external inspection, then what? Like you look into the proc file system, and for macOS you have to have like kernel specific syscalls to get this information.
No, I will do it because it looks like you're confused. No, those tools work by using GDB oh, they use GDB to do the heavy lifting. But they will say, but that is not Python. So what is going on? So this is what they do. Let's say you want the process to activate the debugger. And the process is running there, like it's happy in the field, like playing with flowers.
I see.
And then you come and appear and say like, dude, you are going to activate the debugger. But you cannot communicate with the process because the process is happy playing with the flowers. So you grab GDB, right? And then with GDB, you attach to the process. But now it's CPython land, right? It's the C code and symbols and shit. And then you grab that thing, you resolve a bunch of C API symbols, you grab the string of the code that you want the process to execute, and then you call the C API to execute this shit. Normally in a thread, so you probably will spawn a thread first, and then you will call that in a thread, so you don't block whatever the process is doing, and then the program will execute the process, right? The code. So why is this wrong? Why is this wrong?
Well, because you can have garbage collection happening, but we cannot explain this because the episode didn't come yet.
Oh no!
So you can have memory corruption, and you can have like thread state interference, which causes deadlocks. You can have malloc recursion, so you can have crashes in the process.
Exactly.
You can have like many kinds of catastrophic failures, I guess.
That's a very good, that's a very good list actually of all the things that can happen. I think the easier one to show to people is like, because you don't know what the fuck the process is doing when you are attaching, because it's random shit. Like it could be under a call that has a lock, and the code that you may be executing may have to acquire the same block. So now you are creating a deadlock. Like an example of this is malloc. So for instance, if you're under malloc and your call needs to malloc, then you're calling malloc inside malloc, and that is a deadlock because it's a it's a lock under malloc, and then you're grabbing the same block, and that's it.
Malloc inception.
Yes, but then you could be in the middle of the garbage collector and you're calling the CAPI. So Python is not ready to call the CAPI in random shit places, right? Like for instance, in the middle of a garbage collector run, we will explain this probably in the future, you cannot alter the ref count of anything, because the garbage collector relies on the ref count of things to figure out what is going on, and you can crash it. So the danger with this shit is that it works sometimes.
Yes, 60% of the time works every time.
And sometimes it just destroys your fucking process because it's a stack fault. So it's really, really, really bad. And not only that, it's really very annoying because you need to now ship a C extension, and then you need to rely on GDB or LLDB to work, which is not easy because sometimes LDB doesn't have enough symbols to call the CAPI, or just crashes because of random shit. If someone wants to see how difficult this is, you can actually go to memory and look at a file called LDB hacks or something like that, and you will see how disgusting this whole thing is. So really bad, really bad. It's not cool. So this is where my PEP comes in. This PEP 768. And the idea here is that if you cannot attach to the process, you will make the process attach to you. No, that's not really how it works. But basically, the idea is that instead of the GDB model is you're forcing the process to do shit that you want it to do, right?
Yeah.
And basically, you attach to the process and then you modify the process and whatnot. You use the system calls and stuff. But the idea of my PEP is that instead of this, the interpreter will collaborate with you, because the interpreter will have a mechanism that will allow you to secretly introduce instructions, and then the interpreter will execute it only when it's safe. So and this is the key, because it plays with CPython. CPython allows you to say, hey dude, do you want me to execute something? Place it here, and I will execute it when I can execute it. And that's nice because you can execute it at random shit.
Call later on the event loop.
That's a very good. It's indeed not only a very good metaphor, but it uses a very.
It is exactly the same thing. Only you just have a different loop.
Exactly.
Now you have a C eval loop.
Exactly. And actually, it serves the same code with garbage collection execution or signal, something like that. So by the way, one very cool thing about this is that so I have this revelation. I was visited by the sleep token, the sleep token toxic relationship kind of thing. This is an internal joke. Don't freak out. So I was visited by the gods of debugging, and I was given this knowledge of how to execute these shenanigans that we are going to describe in a second. And then I sleep for a lot. See what I did there? Well, anyway, and then I sleep for a lot of time. And one day I was talking with CF. I'm going to butcher the surname. CF
Bolz-Drake.
Thank you. Sorry. And then, so I talked with them. Basically, they maintain PyPy these days. The alternative interpreter, not the package index. One is PyPy, the other is PyPy. Right? The first is the interpreter. The second one is the thing that you contact to download TensorFlow. Actually, TensorFlow comes from a different place, but whatever. So I talked with them, and they were so basically happy about this that they implemented this on PyPy. So PyPy actually implemented MyPy before MyPy was even accepted.
That's pretty cool.
Inception, ridiculous. So very, very cool, and it proved that it was possible. So how this works? So the idea is that instead of fighting against the interpreter with force code injection, like PEP 768, basically adds an interface where the interpreter cooperates with the debugger, right? And basically, like before we enter like a lot of technical scrap, the way this works is that the interpreter will offer you a secret place in which you can put a file. Important. We will come why it's a file and not the actual code. You will put a file, and then the interpreter, when it's safe, it will read the file and it will execute the file. That's it. That's the whole deal, right? So if you want the debugger to, I don't know, to run PDB or whatever, then you put in the file the PDB code, and then you open a bunch of sockets and a bunch of like pipes or whatever you want to use to communicate, and then you communicate. Do you want the interpreter to change, like, I don't know, to run the GC or to print the modules that it has imported or whatever you want it to do? Then you put it into the file and the interpreter will execute the file. So this is not only it's mainly for building debuggers and profilers, but you can do it to make the interpreter change anything. And this is very cool, and it will come in the later in the ideas of things that can be built on top of this. But that this unblocks everything. Is super, super fantastic. It's exquisite. And the idea is that the implementation also maintains a zero overhead during normal execution. So the idea is that if you don't use it, it doesn't cost anything, which is the best kind of way to do things, right?
Yeah, exactly.
Okay, so how does this work? So first, the idea again is this: like there is a place, you can put in that place the file, and the file will execute it. Now the problem is like, how do you know where the place is, right? Because like every time like you load like a process in memory. By the way, I was told that in Windows, what I'm going to say right now is not true, but like we will come to that later.
Okay.
Yeah. So what happens? What happens with the memory addresses of a process when you load it? Is it always the same?
No.
Łukasz? Why not?
The order of in which you're loading libraries might be different. Like your virtual like address space is assigned every time, and it might not be contiguous. So like it might look differently.
Do you happen to recall the name of the feature in Linux that basically randomizes the address stuff?
Is that the same thing? Like it's not the same thing that we're using for hash randomization. That's different.
No. It's ASLR.
That's something else. Okay.
Address space something randomizer. Actually, I don't know what this is.
So that's a security feature.
Yeah, it's a security feature, and like I think Windows. I mean, Windows has a similar thing, but like Windows is more constant. Layout, like LS layout. So address space layout randomization, and then there is another one called KSLR, which is the kernel address space randomization. So one happens in the kernel, and the other in the user space. You cannot deactivate it, and you can do it. And then when you load Python, the addresses are always the same, but by default always is not. And the idea here is a security feature for hackers, basically. So you don't. It's difficult to know what is the address of some shit that you want to hack. Okay, so that makes the whole ordeal more difficult because every time you load Python, this box where you put the secret file to execute is in a different place, right? And that's kind of bad. So turns out that we already have half of this prepared, and we have talked about this in the podcast plenty of times because we have these debug offsets that we added for debugging tools to basically understand like how the internal structures of CPython look like. We added that because certain people, including myself, by the way, are breaking the debuggers and profilers all the time by changing the structures. Oh no! So we added this secret offset structure that basically describes all the internal structures in a very nice way, and it's very easy to fetch because it's at the beginning of a structure called the runtime state, which is basically a super ginormous structure. And it's so fucking ginormous, Łukasz, that if you try to print it in GDB hangs and crashes.
Yeah?
Yes, because it's so big.
Wow.
It's so big that it hangs and crashes. And LDB, actually, I don't know.
But is that in memory or is that in the binary?
It's in the binary. Because it's where now, it's so big because now is the place where we put the static strings. That was a change done by the one and only Eric Snow. For multiple interpreters, among other things. And basically, if you print it, it prints all the static strings, and that's a lot. So yes, it's quite big. So the runtime structure, but basically it's the structure that holds the entire program, like multiple interpreter, multiple threads. That thing is basically a tree of data structures that hold all the information. But at the beginning of such a thing, there is a secret structure that is called PyDebug offsets, and that contains a bunch of offsets into different things, and you can read those, and then you can understand without having the source code how the internal structures look like. And that's very useful because then you can actually inspect a Python process knowing what you're reading. So that was already there. So we added a bunch of stuff to that basically structure that describes basically where to find this box when you put the code. And there is a bunch of things. Like there is a place, offsets in different places. So basically you need to use these offsets to change a bunch of pointers. There is 2 or 3 pointers that I know because there is one of these boxes per thread, because technically you could tell a single thread to execute, not all of them. So you can say, okay, only you execute the thing. This can be useful in async IO, you can imagine, right? Because imagine that you want to target an even loop or something. You don't execute it in any thread. You execute it in the thread that you want, right? This is different, right? This is different from signals because signals only execute on the main thread, as you know.
That's true.
Right. So the idea is that we put these things, and it will teach basically the thing that wants to find the box where the boxes are. Boxes now in plural because there is one per thread. And the only problem is that now you will say, well, Pablo, that's kind of cool, but how do you find the runtime structure? And this is another secret. Since Python 3.10, all the Python interpreters had a secret thing being burned into the... I was doing this secret thing, right? So I was creating anticipation, and then you did this dramatic zoom.
I didn't even do it. It was just my phone randomly deciding it needs to show you the entire room. I fucking don't know, man.
Okay. So this is the thing, right? Like the thing is that since Python 3.10, there is a secret thing in all the binaries of CPython, in all the operative systems. All Linux, Windows, and macOS. If you are not using one of the 3, then no. But most of the operating systems, the ones that actually matter, so in all of them, there is a secret thing called the PyRuntime, .PyRuntime in macOS and Linux, and in Windows I don't care, but it's similar, and that will tell you precisely where is that runtime thing. It's telling you where is the runtime thing relative to where Python is. So technically, you need to find out where Python is loaded. That is specific to the OS. Like Linux looks at in a different way. Like you need to look at this proc pseudo file system, whatnot. But once you know where Python is, because normally it's not loaded at 0. Actually, that's a funny thing. Our listeners apparently love these kind of little tangents. Do you know why programs are not loaded at 0 in Linux? Łukasz Langa.
At 0? What do you mean?
Yes. So okay. Just the door, like.
Penalty, Pablo. Okay.
Yeah.
Okay, so this is the thing. Whoops, I cannot deactivate this.
Okay, that's the neither. Okay, we know that the memory address space of programs is basically a lie. Like
yes,
if I
virtual.
tell you that this is virtual, right? So if I tell you that I have a pointer that says 64, I don't have really address 64 in RAM. That's a kind of a lie. It's an abstraction, right? Okay, but that's the thing. Okay, so every program can have the same address because it's a lie. Like a real address is some other thing. And there is a page table and blah 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 blah.
Oh, so why they don't start at 0?
So why the virtual addresses don't start at 0? Why you cannot have a pointer that is at 0?
We already have a pointer that is 0, and it's a very bad pointer.
Yes.
Everybody hates that pointer.
Which one it is?
That's null.
No. Yeah. By the way, it's an implementation detail that the null pointer is 0, but obviously it's 0.
Like in Germany, it's 0.
In Germany, it's 0. Oh, okay, I see what you did there. Okay, but what happens when you reference a null pointer?
Well, then the kernel is going to not allow you to do it and send you a signal.
What signal?
Segfault.
Segfault. In German, Segvolten or something like that. Okay, so right. So it will segfault. But what is segfault? It means segmentation fault.
Yeah.
So what is a segmentation fault? It means that you're reading a page that is not mapped to the process. And why is not mapped? Because there is nothing that maps at 0. That's the whole point. The whole point is that there is nothing that maps at 0, so it ensures that when you read 0, you're not reading some random shit, you're just reading nothing, and then you crash. That's why nothing maps at 0. But you could say, well, it could map at 64. Well, technically it maps much higher. There is a bunch of numbers depending if you're in 32 or 64 bits and the alpha specification and blah, 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 blah. But the idea is that you don't map at 0, you map at some random fucking number, and then you add that number to the thing that is we burn into the process, and voila, you know where the PyRuntime is. and then you read the debug offsets, and then you have everything you need to locate the boxes when you are going to write the files. Fantastic. And then, so you write the string, and then you need to tell the process, hey, I wrote the string, because writing the string turns out is not enough. You need to tell the thing, I wrote the string, so please execute. And that's just a bit, like it's a bit in a place, so it's somewhere, and then you say 1. So you need to write to the process. And for that, you use this dark magic thing that Łukasz was talking about in test external inspection. Is that this is just a step further, because test external inspection is just reading memory, but now we are writing memory. Oh la la. Ooh, dangerous shit. And then you write the string with the test to the file to execute, and then you write this byte that says please execute, and then the interpreter every time it goes into the eval breaker, this kind of place when the interpreter pauses from time to time to check signals and the garbage collection and a bunch of other stuff that Mark Shannon added. Actually, like the JIT also does a bunch of invalidation there for some reason that Savannah added. The executors, I think is what it does. But anyway, it pauses and it will check if the bit is set. If the bit is set, it will say someone may have written a file here, and they will read it and will execute it, and that's it. That's the whole thing. Isn't it cool?
It is very cool. So now, like, you only need to have this, like, what, like 500 bytes or so of memory just for the path. So the buffer that you need to have in the process is small. It's easy to write. It's just a path. And the file that you execute can be arbitrarily big. So that is actually good for us.
Exactly.
Right?
But why is also a file? Do you know why it's also a file? Why is not the code? I mean, you say a very good reason here that like...
So I actually don't know, because my sort of expectation would be that being it a file makes it easier for Python to execute the code, because if there are exceptions in it, you can actually show tracebacks. You know which line does what. But in this particular case, if there were any exceptions, like who would you report them to? What would happen?
Well, that's a very good question, actually. I will answer that, but I will answer first why it's a file. True, like the experience is slightly better when there is a file, because exceptions will be better, as you mentioned. BMAC, there is APIs to execute random strings, so it's not particularly easier. It's like exec.
Yeah.
Like you can call exec on a string, right? The real reason is security. And this was a big thing, because as Mark Shannon mentioned, this is a machine to do arbitrary code execution on processes. So obviously, like a very good question that people will have is like, well, and why now? What stops anyone to ask any Python program to execute whatever I want? And this is the key. Well, first thing, the whole thing, we put a lot of effort on this, and actually plenty of hackers and red teams have looked at the draft and things like that to ensure that we are not missing any big things. So don't worry, we made our homework here. But the key here is that to write to another process, you need permissions to write to another process, and that is gated by the OS in all cases.
Yes.
So you need to already own the process. Not only that, you need to have the same permissions as you need as GDB uses. It's literally the same permission set.
So in like in macOS, you need to be root, right? Literally to do this.
Yes.
But like on Linux, to read memory from another process, like all it takes is that it's the same user as you. And how about writing to the process? Is that also true?
It depends. It depends on something you call YAMA, like YAMA. Like is the kernel. If you have the permissions lower, then it's just you need to be on the same process group. So it's either the same user basically, or process group. You can also use sudo, but if you have YAMA on, then you need to be root.
Yeah.
And for instance, Fedora, I think, if I recall, has YAMA by default on, like an Arch Linux as well. So these days, you probably need also sudo. But yes, it depends on, like Ubuntu, I still think you can do it without sudo. But yeah, normally you need sudo. But yeah, that's the first thing that will basically stop you to execute anything. But then there was a bunch of very interesting discussions when we discussed the PAB. And something that was pointed out is that even if this is true, the problem is that if it's code that you write to the secret box, then, and this is a bit tricky to think about, but it's not super hard, then the problem is that imagine that you have an attacker that already has compromised the process, okay? But the attacker only has like arbitrary write and arbitrary writes, but not arbitrary execution. So it can read any memory. My argument here, by the way, is that you already lost. Like if you have arbitrary reads and arbitrary writes, you can do whatever. It's just that it's just a bit harder, but you can do already whatever. But anyway, let's say you have arbitrary reads and arbitrary writes. This means that you can read any memory of the process and you can write at any memory address of the process, but you can execute whatever you want. Right? You can just alter the program execution.
Yeah, okay.
So the problem is that if you now require code to be written, then you can write the code and now you have arbitrary execution. So basically...
Yeah, because it will execute it for you.
So the problem is that if it's code that you put there, then the problem is that this elevates arbitrary right to arbitrary execution. So basically any attacker that has gained arbitrary rights, now it can arbitrarily execute code in the machine. Well, it can force the program to execute, right?
Okay, versus now you need to actually have some other remote code execution to be able to write the file.
You need to have compromised the file system. So that's harder. And if you have compromised the file system and you have arbitrary write, you have arbitrary exec anyway, because you can import a file. You can write to like I don't know. Mail.py in the standard library, so you will write that file and then you do import mail and then you execute whatever you want. Right. So you have already that. This is not elevating anything, but that's the key. Like the key also is that like having a file adds another layer, because like you can also compromise the process by another file system in many other ways, and like the file system has had many different ways to locate if something is writing to the file system. And now you may harden, for instance, a Docker container to not be able to write to the file system, for instance, if you want. I mean, there's ways to deactivate all these things that we're talking about, but the file system is much harder to compromise, let's say. Obviously, you can say, well, I still don't care, Pablo. I don't trust you. so there is a lot of ways to deactivate these shenanigans. One of them, so for softer to harder, one of them is an environment variable called Python disable remote debug. So you set that to 1. Any Python interpreter that has that environment variable will not execute anything. You can also run Python with -x, with -x disable remote debug, and the same thing, that will not do anything. And you can even compile Python without this feature. You can pass without remote debug, and it will not be even compiled in. So that Python will never execute anything. So if you're running on the
hardened
TIA
systems,
or
yeah.
yes, or so that Python will not work without with this.
Right, but by default we want it to be debuggable.
Of course,
since you want to be able to debug production.
Well, not only that, like we want PyDebug to work by default, for instance. So we want VS Code and the VS Code debugger to work. So you don't need to do anything as a user, or you want all these features to work by default. Because again, it's not insecure, right? It's just that if you're running on a hardened place, like how Apple call this advanced security, or no? It's
So Apple Intelligence stuff.
Smart. So if you're running a hardened place, or a company that doesn't care about debuggers because he hates its employees or something, then or for whatever reason you want your production Python to not have this, then you don't have this. But most people will not deactivate it, right? That's very important. We want. This is safe. It's safe enough, and like it's good. It's just that if someone is paranoid, then it's fine. We don't dislike paranoid people. We allow them to do paranoid stuff. That is good. And then you will say, "Cool, I'm a user. What is the main difference? How does this improve my life?" Well, there is many ways it will improve your life. The first one is that we are adding something to the standard library, something very cool, because you will say, I don't want to read the files and find the debug options and all these things. Like that's kind of bad. Like I just don't want to do that. So what did you do? So there is a new API in the sys module, because we didn't know where to put it. So now it's in the sys module. So it's called sys remote exec, and it receives a PID and a file, and it will execute that in the remote process. How cool is that? Isn't that cool?
So now Python processes can talk to one another on one box if they have the ptrace permissions and everything.
Yes. So basically you pass the PID, you pass the script, all you need to have written the file somewhere. And that, bada-boom, then it forces the other guy to execute your thing. And then you can implement whatever the fuck you want. It's very cool. Obviously, like the serious debuggers will re-implement probably the entire attachment protocol, so they will not use sys remote exec because probably they just have a C extension or something. But if you are a user and you don't care about any of this, you now have a bigger weapon. You can do all sorts of cool things now on production. And one thing now, and this is the kind of cool thing, is that so now what is possible? What is possible? Okay, So this is something that we want to do on 3.14 if we have enough time, because we still need to implement the whole thing. It's not too bad, like, this is a bit. So we want to implement it the same way you can attach with GDB. Now we want to implement attaching with PDB minus P. So you will say PDB minus P, and then you pass a PID of a Python process, and then you have PDB, not GDB, but PDB, the Python debugger, working on a remote process. And then you can do anything. You can continue, you can print, you can step in, you can do whatever you want. The same way you can do it with the VS Code thing or whatever it is. Now you can do with PDB. Isn't that cool?
That sounds really cool, but you know what? Like, I'm looking at this PEP, and it says PEP 768, Safe External Debugger Interface for CPython. It has authors and where discussions go, and it has this status on it. And that status says draft.
Well, you're pedantic Łukasz.
No, because you're saying like there's very little time, and you're correct. It sounds like somebody would have to actually accept the PEP.
Well, this is because it's all because the Steering Council, damn Steering Council. Well, and this is true because it's not me. I was obviously not involved in my own PEP. And also, what are you talking about? Like, there is still a month to implement.
I know, but like, it would be sort of like bad form to just do it on last day, right?
We never said last day. What about 2 days before beta freeze?
Oh yeah, that's fine.
Okay,
That's fine.
that's
48 hours, yeah, that's fine.
I mean, we plan to do most of the thing probably next week. Also, we need to figure out
Sounds
Windows,
good.
but like that's different. We can always add Windows as we did with PyREPL. like
Yeah, just tell Dino that it's impossible.
Exactly. Yeah. Dino will present 2 PEPs more with adding Windows support to everything.
And it's gonna be the fastest and best debugger interface.
Well, I mean, even if we don't see PDB minus P, because that probably requires more work than just like 2 or 3 days, but like the still can be implemented on top of this in 3.14, and then we can add it later. But I still want to add small little things, small little scripts. We are still thinking where to put this. Maybe we create a pdb.tools module or something like that has this, because this is a bunch of cool things that you or us, depending on time and on other factors, terms and conditions apply, we can do. For instance, you can imagine a tool where you pass a PID and it prints all the modules that the process has imported. So you know like what the process has imported and like what it has been loaded. That's kind of cool. Imagine, for instance, activating remotely garbage collection. So imagine that you look at your Python process and you say, dude, this guy is using a lot of memory. If only I could force a garbage collection. And then you go and force a garbage collection. Nice. Imagine, this is very common, your process is using a lot of memory. Oh no, I need to use a memory profiler, but obviously a memory profiler cannot attach to a process and just know what the fuck you allocated, because it has not seen it, so it's useless at that point. I mean, you can see from that point forward, but not exactly at that point. But now with this, you can attach to the running process and print every single object that has been created, and then you know what the memory is for.
So another naive question about this project then is that this file is executing something, right? Like that you say you pass the path to a file and you set the bit saying execute my code. But that code executes in a different process. So where does it output a thing that my tool on a different process is going to see it, right? So like, how do you respond to me? So how?
That's up to you, no? Like your process, your file needs to set up some way of communicating. It can be a socket. It can be a file. You can print to your TTY if you want. You can print in a pipe.
So this is entirely not like specified by your PEP. No. Essentially, you're like, do whatever.
Right. Yeah, for instance, when we implement PDB minus P, we probably will implement it with sockets instead of pipes. Do you know why?
Well, like it would be cool if it worked across computers, but it cannot. But it can work across Docker, like hypervisor.
Well, it can totally work across computers, but the real reason is that what OS doesn't have pipes.
Windows doesn't have pipes.
No, I mean, it has something close, but like the most of the inter-process communication in Windows is sockets.
I see. All right, so that makes sense, but also that will actually work across a hypervisor, I guess, right?
Yes, I think so. I mean, and it will cross across network for sure. If you can, like, I mean, the first attaching probably not, but like. You can start a server basically, and then you attach to the server somehow.
Yeah, I mean, like inside the Docker, you would just have to just execute this code that would say like, hey, just attach to this socket, and the socket actually goes to the host VS Code or whatever, and then you can actually so like that would be a good experience. Yeah.
Right. So yes, like that will be, but it's agnostic, as you can see. Like it's up to you to decide how you want to read the result. Like the process will execute. Where it prints is up to you. Obviously, if you call print, it's going to print it in the standard output of the process that is executing, which is
which is weird. Yes, like I expect like first experiments of users might have like naive issues like that, where you're trying to do something, but you're in a different processes memory now. So
but you're playing with dark magic, right? Like if you're playing with dark magic and you don't understand the result of the dark magic, then it's like, dude, it's you. It's not like, you know. But yeah,
sys exit one.
Exactly. Just guess who is going to exit. Also, like there is a bunch of caveats. For instance, so if this file raises an exception, it's going to print it, but it's not going to crash the process by design. It's like the same thing if you're raising a thread. Like raising a thread doesn't crash the process; it prints the exception, but doesn't crash. But yeah.
Oh, okay. So this but it will print just to standard error or like somewhere.
Yes, on the process.
Needs to, okay.
On the process. Yeah, but they make sense. Like imagine that you're running on production and then you're capturing the logs of the process. You want to see that process saying like, "Hey, I execute this shit and it crashes." But I'm not crashing. This is like the error. You can
and the execution of that is gonna raise an audit.
Yes,
event.
Of course. That's an excellent point, by the way. Every single time this goes through, is going to execute. It raises an sys.audit event. With the code and the time and all that stuff. Yes, indeed. And also that happens even if you don't use the sys.remote execution method. Like so if you want to know if this is happening, you can know it. It's very easy. Also, if you want to also redirect the errors to your tool, you could basically wrap your entire file in a try except, and then in the except you send that to the socket.
Yeah, I like that.
Yeah, which can also raise at that point.
Sure.
Like, so you still need some backup to print in the process, but like you could ignore and make the process not have to deal with printing stuff. But basically, we want to add a lot of little things. For instance, one of the first things that we want to add, hopefully in 3.14, is the ability to change the login level on the fly. So if you want like a process and like the process doing weird stuff, but you are logging in warning, you can say, "Hey, dude, like what about logging in error?" And then the process will log in error.
The other way around, like, you know, like logging error only logs errors. You want to log debug, so like it logs everything.
Exactly.
Now.
So you don't need to restart the process. That is very cool. Like for instance, you have your web server, and then you can tell your web server, or imagine that you have like some other debug system in your. For instance, imagine that you want to expose a bunch of feature flags. This will be a very cheap way to enable your feature flags, right? Because like you don't need like crazy systems. Imagine that you have a web server and you have a secret admin console that normally is deactivated, and then you want to activate it only for debugging purposes, and then you want some crazy authentication for that. So you can implement whatever you want in this system. Like the heavy lifting, which is forcing the process to do something, is provided by us, and then you implement whatever you want on top of this. So this is really cool. I think people are going to love this.
Yeah, there's quite a few things, or even like in PyREPL we do stuff that is just based on environment variables. So you could make those things like actually on the fly. Like it doesn't make sense in a REPL, like you're Lily in a REPL, right? But like all I'm saying is like a lot of software is configured by environment variables, but once they are set, they're set. And now you would be able to change them on the fly in a running process.
Exactly. Yes. So it's very cool. Like also like you can, apart from this, you can do all sorts of things with tools. Like for instance, memory profilers and like performance profilers and whatnot, like can now do a lot of more heavy things to the process. Like so, for instance, they can read all this memory to the process because like they have control of it. You need to deal with the fact that there is a small delay until they execute the code normally, because if it's basically doing something in a C extension, it needs to wait until it reaches the eval loop. But yeah, like. So maybe there's some tools that still want to do the whole thing, but in the most tools will probably want to port to this. That's our guess. But yeah, that's the whole thing. What do you think, Łukasz?
Very impressive.
You like it?
I hope the steering council accepts it.
Yeah. Well. I have news. Actually, so the rest of the steering council minus me, because obviously I'm not allowed to be on the decision of this. I actually accepted 3 weeks ago, but we are a bit slow. As we published recently, because we are struggling a bit with times and whatnot.
I see.
Yeah, it's quite hard because like we have one person on every weird time zone, right? Like we have people in San Francisco, and then we have people in London, and people in Korea, right? That's when.
Right. So this is bad enough normally. The meetings used to be very late. Now they are sort of in the middle of the day for me, which is better. But we are in this strange world of the United States is already in daylight savings, whereas Europe is not. And this week in particular, the difference is 3 weeks between Europe adopting DST after the US did. So you know why that is? Do you know why that is?
No, I have no idea.
So it turns out that the way the US changes to daylight time is on the second Sunday of March, whereas Europe decided to always go with the last Sunday of March. And this year, since March started with Saturday and Sunday,
Right.
the difference is 3 weeks and not 2 as usual, which is extra painful. If I created a meeting in Europe, then my US friends will see the time shift for those 3 weeks. Whereas when Americans create a meeting, I will have the meeting's time shifted for 3 weeks. It is extremely confusing because sometimes those are meetings with the same people, so they start conflicting for 3 weeks.
So yeah, it's really bad because like Don Heina needs to join at like 1 a.m. or something like that. And like for the US, it's like super early in the morning as well. And for me, it's like super late at night. Right now, with this 3 week bullshit, it's in the middle of my work day, so I need to like excuse myself from work and like join the meeting. So
that's a great excuse, though.
Yeah. Well, I mean, depends who you ask. But well, yes. I mean, it's complicated. But yes, like like we do our stuff and we discuss PEPs, which we have a lot. We are also ready to accept the tag string thing, as we announced recently, and we put a lot of notices.
Ooh.
Yeah, there's a lot of.
That's awesome.
Yeah, we need to bring Lisandros maybe soon to talk about.
Yeah,
tag
I
strings.
just recently sponsored a PEP, which is the mscript and platform support. But we're hearing from the packaging people that they want 2 PEPs because 1 PEP is just not enough for mscript. And no.
More PEPs for the PEP god.
Yeah, because the platform support should be 1 PEP and the PyPy related stuff should be a separate one. So now Hood is splitting his PEP into 2. And there's going to be 2 PEPs for... no, actually only one for the steering council to stamp.
I like that.
And then the other one is the PyPI people.
Or you could do an informational PEP. The best kind of PEP.
Yeah.
Okay, so we were a bit late because like we are supposed to, well, I mean, I suppose it's our fashion, right? Like we are always a bit late with episodes. We are also late for the news section of 2025. Bets. Bets.
Totally legal.
Totally legal bets.
Not investing advice.
Especially not now in 2025. The stock market is going to shit, but not our bets. We are a men of, gentlemen of, our word. Okay. So we reach out to Widow, and we do have an answer. For those that don't remember our last episode, or worse yet, have not listened to our, well, not technically the last episode, it's 2 episodes ago, but like,
Yes.
Okay, just go and listen. It's very fun. Like Łukasz put a bunch of like funny effects. I hope he puts again here.
Yeah, you're not the only one with effects.
Exactly. Okay, so the question for the news section bets was that Łukasz and I bet for the following thing. We were debating if reference counts or the semantics that are imposed by reference count, like what was the order between those two? Like it was first, like Widow chose first reference count and then the semantics were like derived from that, or the other way, the semantics were like chosen first and then like there's several implementations of the semantics, but like reference counts is one, and then he chose reference like that one. So we check actually because we didn't remember who actually bet on what side, but like but now we have the information for you, our listeners. So apparently, I bet that reference counts was chosen first, and then that basically constrains the semantics. And Łukasz actually, just for the record, because like as you will see, he's going to win. But like he actually thought that I was right, but because I chose first, he was basically left with the other option. So semantics first, and then reference count. But it turns out that he was right. So according to our agreement, I need to say I was wrong, and Łukasz Langa was right. Łukasz Langa was right.
Yeah,
and
I
was wrong.
stumbled right into that one.
Interestingly, Guido told us that originally, basically, he was looking at ABC. ABC is the Python predecessor language. It was not designed by Guido. It was already there. And turns out that ABC does a bunch of weird stuff. In particular, it puts a lot of like, well, I don't know if is the correct tense for this. Like, nobody's programming in ABC anymore. Used to put a lot of, emphasis on mutable and immutable. And it turns out it does like quite a lot of weird stuff that actually resembles what Yuri was telling us in the last episode. So apparently all data structures in ABC were immutable. Immutable. And then when you mutate them, basically they were implemented as B trees. And then when you mutate them, it creates like branches of the B tree and whatnot, which Guido didn't particularly like. But he basically separated the objects in the immutable objects and the mutable objects that were a bit bigger, and only those that had dynamic memory, for instance, leaks and dictionaries, but not tuples or strings, were ref counted and mutable. Obviously, we were discussing what exactly this means. Probably that means that the small ones were always leaked for a while. But that was kind of okay because, like, not a big language, Python.
Yeah, like it was supposed to work for scripts up until 500 lines of code, right?
So, then Mark Shannon upgraded that to 1 million lines of code. It's the best, Pep. He should have done that. He then, so Guido then mentioned that, interestingly, he liked the semantics of C for this. In particular, he puts the example that he liked this idea of like having a list that is empty, and then you pass the list to a function, and then the function like fills the list and is the same list, as opposed to that the function needs to create a new list and then return that, or copy the original one and then fill the new ones and return that thing.
Right, but Guido does admit that passing a list as a default argument is now sort of like a design wart.
Yes.
That it is problematic.
Yeah, he mentions that this, and indeed that's the case, that this has worked quite well. For the most part, and he mentions 2 examples that maybe it doesn't work that well. One is for people coming from C and C++, but because those are already, quoting, I think it's Distra, regarding BASIC, those have their minds totally destroyed without any possibility of redemption. And then I code in C++ in my job a lot, so that checks out. And then yes, it's true, man. C++ is a ridiculous language. It's a joke. Again, that's my main language these days. Maybe Rust as well. But anyway, and then the other thing is the corner case of mutable defaults, which that bites everyone. And still, even today, like we were discussing how useful will be to not have that, but has been proposed as a PEP.
It will be useful, but there is no elegant way to get there. Like
someone proposed like a weird equal, some weird shit. Let's add more weird stuff to the function signatures. I'm surprised nothing will break. It's the worst part of the grammar. There was a PEP that was rejected recently that wanted to add this like half equal. So if you are passing by default like a parameter that has
you don't have to repeat the name of the variable, like as long as they're the same as the keyword argument name.
Right. I'm contractually obligated to not reveal my particular opinion because we decided the steering council would reject it, so we are a single hive mind entity. But you can say what you think about it.
Right. So pragmatically, I wouldn't be offended if it was added because it would sort of, I predict, be something like assignment expressions where everybody's like tearing their hair out and saying, oh no, it's going to destroy the language. But in fact, it would be used very rarely. But I think it would be used very rarely because the design is sort of limiting the usefulness of it. Like the fact that the name would have to match is just annoying. Like there are plenty of keyword arguments that will just not really fit very well to your locals. So I think like, yeah, it is problematic that there is no nice way to map like, kind of to pass defaults on, especially in decorators. But I do feel like this PEP, what it was proposing, it was only solving part of the issue. So personally, like when I read that it was rejected, I wasn't shedding a tear. But if it was accepted, I think I would use it more than once.
Right. There is some. I mean, we don't want to like extend this because spoiler, we are recording this after we recorded the actual episode, and we don't want to make it even bigger. But like, I suppose there is also something to say about this special subset of grammar addition that is just to simplify the grammar. So not that really adding new features, just typing less characters, Like really what people normally agree on is that what matters really is the final, it's not that you are skipping the character, it's like how is the burden of reading it. And like when you find this equal hanging out there, you need to like pull some extra mental cycles to say, oh, right, like that is an ellipsis for what you should have written, which is the parameter equal parameter. That may or may not be my opinion.
Yeah, it almost made more sense to have the equals on the other side, but I don't want to reopen the bike shit because obviously it doesn't compose with types now, and it's terrible. It's like
it's like acronyms, right? Like if you don't know the acronym, now you're like, what is this, right? Still, and I always like a blog post, man, just write it. Like just write it. Don't say like the NRTP method. No, lol, man, just write the thing. Write the thing. It's free. It's free. Like, no. Just write it. Okay, so this is the same. Okay, that's it. So just to be absolutely clear, I was wrong and Łukasz was right.
I'm pretty sure next time is going to be the other way around.
Next episode, more bets. Section of 2025. Hopefully we will one by one, not like one every 2 episodes. But
do you want to bet if it's actually going to be in 2 weeks?
No, because like it should be things that we don't have control over, right? Because then you're like, oh no, my leg, I cannot record.
It's insider
I
trading.
I cannot record my leg, and like now I
not
lost.
Investment advice.
Not investment advice.
Right, but something that we do have control over is actually talking about
PR of the week.
All right, you have been talking for quite a bit in the first 2 sections, so let me start with my PR this time.
Okay.
Which is actually a few PRs, but like the main one is now currently open. It's 131562, which is adding syntax highlighting to PyREPL.
Wow.
What? You sound excited.
I guess nobody will want to configure that.
Right. So, first of all, it's one of those things that everybody, when they saw the colored prompt, was asking for. Like that's one of the most requested features to add syntax highlighting. So I based it on idle colorizer, since that's a syntax highlighter we already had with idle for a long while. And I'm hearing from Pablo, he's not really excited about that.
No, I hate it.
Why not?
Okay, I don't want to offend anyone, but like I hate it because it's doing
Illegal. No bueno.
Yes,
but no, like there's only one illegal language.
It's C, the illegal language. No, this is Python, the legal language.
Turns out that there's another illegal language for Pablo.
Yes, regular expressions is parsing. Dear listeners, this is what is going on. So this code is parsing, doing some parsing with regular expressions. This is the thing that you don't do. If you go to fucking Stack Overflow and then you say, can I parse HTML with regular expressions? No, you can't. It's proven. It's mathematically proven that it's not possible. Not possible. But this code is doing it. Which, what it means? No. Say it out loud. What does it mean then? What does it mean if it's doing it?
It means that it is incorrect.
It's incorrect. Exactly.
Cool.
Incorrect.
Okay. Cool.
No, not cool.
I would be embarrassed about this. I would be like, yeah, we should probably do something else. But I'm not. I regret nothing. And the reason why I regret nothing is twofold. Actually, maybe I even have more reasons, but let's start with 2. So reason 1 is like idle has been doing it for a long while. So if it's good for them, it's probably good for us. And if it's not, we're going to expose the fact that this colorizer that idle has is insufficient, and we're going to fix it for both use cases at the same time. So, teamwork. I think it's better for us to do like the same thing in multiple use cases and not have multiple syntax highlighters in the standard library. But also, and that's the second thing, the alternative for us with having a second syntax highlighter would be to actually hand roll some of hacks of our own. And why? Because there's only like one thing that we know for sure, that you have tokens, right? Mm-hmm. And you have tokens and you can use a tokenizer and it's going to spew tokens at you, but that will not actually do any parsing, right? No. Like those are only going to be tokens. Yes. So those are just numbers for like attached to your strings. but you need to have some sort of rules for like the soft keywords for match and case. So you'd have to have some sort of hack for this anyway. And now it turns out that we would have to either do something very similar to what idle is doing, which is use a bunch of regexes to figure out that, oh, there's a colon at the end of the line or something. So we do something very similar.
But why? No. Because no. Because like, firstly, that is not nestable. Because if you do match, case, match, case, for instance, you can do that, by the way. The parser is that cool. I wrote that. Anyway, so you do that, it will not recognize the second match because it's not nestable. Like the regular expression cannot deal with this nested shit. So you say, well, who is doing that? I'm doing that. It's not working for me. Google, fix it. Anyway, you can still do it with the tokens. Like you have the token stream, and then you say match column, and the column can be in another line for whatever it matters. I mean, technically no, but whatever. Like it's cool. So you just look at the stream, and then you say, okay, what is is there a column later in the line? Like yes, okay. So there's a match statement. No, okay, there's not a match statement. That's it. Very easy. You don't need regular expressions. You don't need to deal with the source. No source. Very easy. No source. And with case, it's the same shit.
But we would need to have some form of parsing on top of the token stream. Like, just the tokens are insufficient now because of the peg parser we have soft keywords.
But it's a restricted language because the only thing that you need to know if it's a soft keyword or not. Like you don't need to know the structure and like you don't need to deal with what a parser really does, which is telling you if it's a valid Python program. Like you don't need that.
Oh, here we would actually not want that, right? Because you want the syntax highlighting to be incrementally correct. And not just flicker all the time when it doesn't actually produce a program that is valid. Yeah.
Exactly, but then you still need to do some weird choices. Like for instance, when the user is writing match blue, like before he sees the column, what is you going to say? You need to assume that it's a soft keyword or not. I should probably the best thing is assume that it's not. And then that is a soft keyword, like so it's a name. And then only when you find the column, then it says whoopsie, and then it changes. So, but still, like that's good. Like you basically analyze. But we will talk offline. Wow, offline. That's a bit of business term. But it's very cool. It's very cool. But the important thing, Łukasz, is like, what colors are you choosing?
The default colors sort of look like Vim, and they use the ANSI colors.
What theme? What is the theme? Can I change the theme, Łukasz?
Currently, there is no theming, but it is something that we need to add for 3.14. But this is going to be a separate change, and there are multiple reasons for that. There is a lot of color in Python 3.14 on top of like this little syntax highlighting in the REPL.
Yes.
There's colors in unit tests now, right?
Yes.
There are colors coming to argparse output.
Wow.
The colors we already had for exceptions and for the prompt in PyREPL and so on, like would be cool if they would be configurable as well, and so on and so on. So yeah, all of this calls for theming support. So that's going to be a separate change. But before we get to that, like syntax highlighting, there were a few refactors, fixes that were necessary like before I introduced this. So we did that, but the change itself is still open. It might be open for a while. I am going to like do my best for it to land, for the last alpha. So you can play with it before beta 1, where it's really, super late now. Like it's just bug fixing time.
I mean, you're talking as is landing after alpha is like evil and whatever. Like it's fine. Like that's what the alpha is for.
I know, but like this is such a visible change that I'm pretty sure like people are going to want to see like what the.
But we know for a fact that the amount of people that tested the alpha is low. So like it's mainly system integrators, not people with the REPL.
All I'm saying is that seeing syntax highlighting in the REPL might just be the reason why somebody might actually go ahead and build Python. Like, because why not?
Wow, actually, that's a very good point.
Right? Because like it's a visible change. It is very silly, but I talked to E on our meeting yesterday, and E told me that like they are now upgrading all Pythons in the entire PSF fleet to 3.13 because they cannot live without PyREPL anymore.
Wow.
That like having multi-line editing just feels so much more like usable than having the old
my
REPL.
heart, man. Oh, and the color as well, because who added the color? This is Pablo's episode, so I can be this annoying. I added the color. Yes.
That's nice. And the thing is this. I played with the syntax highlighting for like I guess it's the second week now, and whenever I check things against Python 3.13 that doesn't have it, it also feels the same way, that like it's old now.
Oh man, I'm very excited. I'm very excited for this.
If you actually start seeing this colored code like day to day, and then you see a Python without it, you're like, something is wrong.
How
right?
cool
Like,
it
so,
will be this? Like so everybody will start Python and it will see PyREPL and then it's like, this is Łukasz work. Like every human on. But this is, do you feel this as a core developer, right? Because like, oh, people are using my code on like multi-billion-dollar blah 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 whatever. Like, you know, that thing passes very quickly because then the bugs appear. But like this is kind of different, right? Because like every single little student that opens the thing and like is welcomed by colors. That is you, Łukasz.
yeah, that would be cool.
That this warms your cold heart, Łukasz Lange.
The black heart, yes. Right. So before we get there, like the PR is there. You can test it works, but it does have a few kinks to work out. The main one currently is the obvious most important production test of PyREPL, the Frankenstein test.
Frankenstein. Yes.
Yeah, so currently we're 4.5 times slower than without colors, which is not good. Not good. That's because of the regular expression. So we need to profile and see like what I can improve for it to not be that much slower to paste. Because like
that's stupid. Why Frankenstein is a string? You shouldn't be colorizing inside a string.
No, because like you are.
Yeah, but
like,
the moment you know that you're inside a string, then you say whatever. That's the smart thing to do.
Cool, but like when you
Pablo was right. Pablo was right all fucking along. You discovering it live. You are discovering it live. You are discovering it live. You are discovering it live. Yes. I'm very happy that this is happening. Łukasz, this is your fault because this is the problem with fucking regular expressions. Do you see? Do you see it now? Because the string is you are dealing with the correct thing. It's a token. And what is a token? It's a number. So your entire Frankenstein shit is the number 6. And what is not slow? To say the number 6. But do you know what is slow? To deal with the source. And this is the fucking problem. That your regular expression is dealing with the source, not with the tokens. If you only deal with the tokens, you don't need to deal with these things. So it's not slow. Isn't this cool?
Yeah, it's a good point. However, I'm using whatever we had in the syntax highlighter that was already in Python.
Not as good.
Yeah, as I said at the beginning, I'm not entirely against like fixing the colorizer for both idle and PyREPL.
No.
But it would be awesome to just use the same for both. So that's
Kids,
why.
say no to regular expressions. No. Well, I mean, sometimes. I actually like them, but not for parsing. No parsing.
You know what I've heard? That regular expressions are no longer a challenge for programmers. They're only for us, but like for the entire like new generation of programmers, they're like, yeah, you just ask ChatGPT.
Yeah, and he throws a fucking exponential, accidentally quadratic regular expressions to you, and then you're fucked. And he's like, well, I don't understand my regular expression anymore. Why is it slow? So only sometimes.
Yeah, right.
No.
Yes, so in any case, we need to profile why it's that much slower. Maybe we can do something that is not super crazy, like invasive, to make it less embarrassingly slow. Because like you don't feel it in regular use, but like
And you're triggering me.
Yeah, pasting Frankenstein is important for us.
Yes, very important.
It wasn't for me initially, but it turned out that more than one user started issues on our tracker using Frankenstein, the entire book, as an example. So now we are treating it
we're 4 bucks in.
like as an official benchmark.
Yes. We should add under Frankenstein already. Like
The current unit tests of PyREPL are slower under syntax highlighting, but they're like not that much slower. It's literally like 16.5 seconds versus 19 seconds with syntax highlighting.
Acceptable.
Yeah.
But it's not acceptable to use regular expressions.
Yeah, but the Frankenstein test doesn't look very good. Yeah, this is sort of the worst case for that test. So we're boiling oceans for no reason.
Yes, it's incorrect.
And by the way, do you still remember what IPython is doing at the same time? It also syntax highlights and it does everything. So like, how long does it take for the entire text of Frankenstein to be pasted into IPython?
Oh, but less than we do, right?
It's instant. It just happens like instantly. There's zero wait. It's faster than like basic REPL in Python. You know why?
Oh, because it deactivates syntax highlighting?
No, it still keeps the syntax highlighting. That's the best fucking part.
So why is instant?
Yeah, because they are entering alternate mode when you are doing bracketed mode for pasting. So when you're pasting, it's like, okay, you don't have to output everything. It is just taking the entire input, like, from the console, and then just goes like through the syntax highlighting without outputting anything. So it doesn't actually assign any colors until it reaches the last lines that you can see on screen, because the console is only that big and it only outputs the last lines.
Oh.
It is a big optimization that, like, kind of you just enter alternate mode. You don't output line by line.
It's
very
that
smart.
sounds like something we should do.
Yes,
Okay.
that sounds like, because like today I was just like amazed after just this like round of pasting into old repos, new repos, and whatnot. I went to IPython and pasted it, and it just like boom. I thought, like, wow, it just felt like alien technology, and it's just this. It is doing everything in memory.
But then that should be very easy to do.
Yes, it should be pretty doable, like for 3.14 still. No promises, listeners, but like we're gonna attempt that.
Nice. Live developing. That's cool. Well, my PR of the week is actually very lame compared to this magnanimous action that you did for the humanity. Mine is almost like a joke. So someone discovered that there is an Easter egg in Python. There is plenty, but like, by the way, there is a secret Easter egg in Python 3.14.
Yeah.
People have not found it yet. Well, yes, actually someone has found it, but we won't say. Anyway, there is one called from future import vary as flufful.
Friendly language uncle for life.
There is if you know, you know. So the problem is that if you do from future import vary as flufful, then the not equal character, which is 2 characters, is like exclamation mark equal. That's not equal.
It's a diamond.
No, it's a diamond. It's like less than and bigger than, which is the mathematical correct term, by the way, but for another day. Anyway, and that actually works. Very cool. Unfortunately, turns out that if you put it for instance, in the REPL or as code, if you put it in the same statement, so you do like import from future import variables flufful, and then you do print 1 less than bigger than 2, it complains. Also, if you compile and then you pass that same string, it also complains. Why? Because like when you run the parser, you need to be told, like the parser needs to be told to activate that feature. Basically, when it parses, it needs to be told what is the real not equal expression, right?
Yeah.
But the problem is that here, this is happening on the fly, because like when it parses this like from future import variables flufful, then the parser needs to change modes, and that is not something that was happening. What happens is that this is being pre-processed first, and then like when it's pre-processed, then it calls the parser and it says, okay, activate this fluffle.
Well, but come on, like that's easy. Like what you need to do is you need to find a place in the memory where you just put a path to a file and then a bit.
Here it is, remote fluffle.
Yes, remote vary as remote fluffle.
Yes, but that's how to do it. I actually look at this back and I said, technically it's like not correct to do this. Like the parser, the purity, like pedantic Pablo without hesitation. So pedantic Pablo says that this shouldn't be fixed. This is not a bug. It works as intended, because like the parser should be told how to parse. Not it shouldn't discover how to parse in the middle of parsing, right? But technically it's kind of ugly, right? Because like this will work. So my magnanimous heart decided that I will fix this bug, even if it's incorrect. That's how generous I was feeling or something.
That's pretty cool. And also like this, you treated this as a bug fix. So like the next 3.13 and 3.12 will also have this.
Not sure. Did I? Let me check.
Yes.
Oh, okay, I did. Wow, I'm extremely magnanimous. Yeah, technically it's a bug. What I can say.
Steering council member doesn't recall a steering council decisions.
The steering council member doesn't recall many things. Yes. Actually, just to be absolutely clear, you will say, well.
I need to show you something.
What?
When I said like steering council person, whatever, the phone heard this as Siri.
Oh.
And it was like calling steering council something.
No.
Like, there was.
Who is the steering council? Which one?
But it was like I don't have a phone number. Do you want me to check ChatGPT to get a phone number to the steering council?
The phone number, I will be interested on such a technology.
Yeah.
Okay, so someone, when we were discussing if this is a bug or not, someone pointed out that, but actually a much better, obviously not, but a much better Python, an older Python used to do this because the Python 2 era future imports used to change the Python on the fly.
Yeah.
You know, which what future import changes the Python, the parser on the fly?
Division.
No, well, not technically. That changes the meaning of division, but not the parsing. Is print function from future import print function. Do you remember that from the old days?
Oh, right, because that's a different grammar. Then.
It's a fucking different grammar. Well, kind of. Do you know what? And I pointed out that yes, that is true. And you know how that code was called? It was called future hack. Why? Because he was not using regular expression, he was doing something disgusting. Yes, not great. But I did a much better thing. So I added cool technology. The PR is actually very cool. So I added cool technology so the parser can change the mode on the fly. Wow, amazing. The parser can change the mode. You will say, how is that a hard thing to do? Well, it's really hard because you need to make the parser resilient to change its entire configuration on the middle of the thing, right?
Yeah.
So very cool. It was actually not that hard. It's 50 lines of code. What about that? That's how good I am. It's very cool.
Still, I'm impressed. Like, I remember from lib 2 to 3 times, which, by the way, like Black is still using to today, that this sort of entire print statement thing like was big because we at least had a future import for this, but there are more changes that made something that you didn't used to be a function into a function in Python 3. You know what also changed? Besides print,
Unicode.
No, like strings, sure, but like what thing used to be a statement and now is a function?
Asserts, no, a statement.
That's still not a function call.
The statement and a function.
Exec.
All right.
Exec used to be a really weird syntax, and now it's just a regular function call. So, like for lib 2 to 3, you had variants of the grammar with this, but you need to literally choose the combination.
Right.
Which one do you want? Do you want exec as a function but print not as a function? Do you want like exec as a function and print as a function? Like so like there's 4 options. So like it's crazy.
Okay,
so, yeah.
I need to say this because this is very cool. Look, so you look at the PR, it's 50 lines of code because it's kind of interesting how it's done. But this is the kind of thing. I'm very excited to say this, and I have 1 minute because otherwise we're going to blow up this episode. So this is the thing. From the point of view of the theoretical world of parsers, which is a very niche thing that nobody cares about except me. This is so cool. This is called a substructural grammar. Why is it called a substructural grammar? The following, because you have your grammar, and at some point in the grammar something happens. The parser changes modes, and then the grammar fundamentally changes. Even if it's a configuration thing that lives in the data of the parser, it's changing to a lib 2 to 3 style different grammar. It's just that you didn't need to write it, right? But technically it's doing that. So you need to visualize it that from that point on, there is a sub-grammar inserted in the grammar. Like, do you know what I mean? Like,
yes.
When you're parsing, I don't know, a file or a statement or whatever it is, and then you change mode, and immediately there is now a sub-grammar being basically created from the void. Like, bloop, it appears there, and it lives inside the other one, because when it recurses back into the first one, you can choose the mode. It can go back to the old mode, or it can keep the present mode. But this inserts a new grammar inside the grammar, basically extending it. That's called a substructural grammar. And that has all sorts of weird combinations, because if the older grammar has some properties, then you can basically like translate those properties inside the inner grammar. And there is a bunch of things, like there is a pumping lemma for this shit, and there is all cool things that you can prove depending on the 2 languages that you're composing and what you're changing. Obviously, if you change it too complicatedly, you cannot prove anything. But you could prove some things. And in this particular case, because it's just a token that you allow and not like it's very easy.
Yeah, it's a relatively safe mutation.
Yes.
But I can imagine that it might be sort of dangerous if it wasn't, right? Because like PEG parsers, they just like go to the first rule that applies, and then they're like, okay, fine.
Well, okay. This is very an excellent point that you're making, because the PEG parser is probably one of the few parsers that will survive this or in any case, because the peg parsers will always give you a parse tree. That's the property that they have.
Yeah.
Like it will always resolve to something. I mean, unless
but
they
it
resolve
might
to
be
nothing, right?
it might be surprising.
Exactly,
though,
maybe
right?
it's random, but they will survive it because there is many parsers that will abort even if the program is valid. That's fundamentally that's the worst nightmare of parsers, that the program is valid, that you fail. You know, but like it's just because the structure of the parsers, you cannot alter the parse tables in the fly. But the back parsers will. But what is cooler, the reason this is easy is because the diamond doesn't mean anything, right? Like if you write the diamond in normal code, it's a syntax error, right? And the same way, like if you write like not equal in a barry fluffle parser, then it's a syntax error, right? But imagine that you switch them. Like imagine that the diamond has a different meaning, and then this thing just switched them, right? Now you can imagine how complicated this will be, because like now you're reinterpreting the whole rest of the program, even if it's the same structure, right? So it gets very complicated when you swap behaviors. Like it's just like, or you alter behaviors. Like from here on, this means something different. So a normal parser will freak out in that point, because the parse tables basically, like for instance, depending on the technology you're using, LL1s will not survive this.
Yeah.
Like with there is some lemmas depending on the K in LK, depending on the push puff like conflicts and whatnot. But yeah, all sorts of boring things that nobody cares about. So let's move on. But I love this thing, even if it was a small PR. So yeah, thank you everyone that was in that PR and pushed me to fix it.
Yeah, impressive.
Awesome. Let's move to our last section.
What's
going on
in CPython? All right, so let's start with my favorite batch of changes every time we're talking about what's happening in CPython. So that's going to be free threading.
Free threading.
Let's start with Thomas Wouters. So he wrote a free threaded specialization for iter, which is very cool to see. So now we have an increasing number of specializations enabled for free threaded Python, which means it will be less slow in 3.14. So that's great to have. And while that is happening, a lot of people are noticing sort of I don't know, like terminology shifts that are kind of necessary for Python users, Python programmers. For example, a lot of CAPI documentation just said stuff like color needs to hold the GIL, because that was true for many CAPIs. But now, with this world of free threading, that sort of statement doesn't make any sense anymore. So how do you communicate what that line was supposed to communicate? So Peter Bierma actually did like a holistic pass over the entire documentation and came up with a term that is called attached thread state. So instead of saying color needs to hold the GIL, you're going to say color must have an attached thread state. And that essentially means that it is a thread state that is active for the current operating system thread.
Right.
So when a thread state is attached, the operating system thread has access to the full Python CAPI and can safely invoke the bytecode interpreter. So now there's a glossary term about this, and all the docs are modified such that this is the term used. So you're going to be seeing this much more from now on in the docs of Python 3.14 and forward. Not sure that was actually backported to 3.13. Probably not.
I don't think so.
Let me just check. This looks really as a change that is only coming for Python 3.14. Right. So there is a bunch of new thread safe operations now, like the reversed iterator that was sort of hard to actually make thread safe. itertools.batched, as well as concurrent iteration over enumerate are all thread safe now. That is thanks to Peter and the back. And then Tomasz Pyttel made the readline module thread safe. Sam Gross fixed data races in dict pop item. But the larger change that is sort of still in flight is to make operations on frame objects thread safe. A bunch of them are already thread safe, but if you are concurrently trying to check somebody else's line numbers, that might still crash interpreters, but like we're getting there. So yes, a lot of changes for free threading. And now let's move to
Performance. Okay, so ASAP new. We need to start with ASAP new. Łukasz, I'm very sad. But apparently, this is an interesting story. I'm quite happy that in some way that this happens. But unfortunately, let's start with the sad thing. So Ken Jean's impressive tail call interpreter that was apparently that wasn't that fast. It's faster, but it wasn't that fast. We said 20 to 30% speed ups or something. That is not real, unfortunately. And this is a very interesting story, to be honest. Basically the gist here is that when we benchmarked basically how fast it was, we turned out that we were using Clang 19 with and without these features. Turns out that Clang 19 has a bug, and it makes that if you don't use these features, then the code is slower. So Clang 19 basically had a regression. That's the thing. So when you were using Clang 19, the code was slower than using Clang 18 by a lot, actually, and which we will have catch. Obviously, we test with every version of Clang, which we don't because that would be insane.
Yeah, so and actually that is also interesting. That's not something that people understand. Like, so why don't Python benchmarks use Clang 19 but use Clang 18? Why is that?
Because the JIT needs Clang 19 to work.
So okay, like, but the reason why we are still staying on one version of the compiler for a longer time is that changing versions of compilers invalidates your historical like results from your performance benchmarks. So if you want to be able to compare with history, you cannot just willy-nilly change the versions of compilers all the time, which is why
this is a very good point.
Like it's conservative for us to upgrade the version of the compiler on the on speed.python.org.
The problem is a bit deeper actually, and I have to deal unfortunately with this because I maintain speed.python.org partially, and the problem here is that it's not just the compiler, it's the entire thing. Like the problem is that every time you run sudo apt-get this upgrade or something like that, now what you say happens, and unfortunately you cannot change Clang only. I mean, you could compile Clang, but like this system is old enough that maybe you cannot compile Clang 19 easily, right? And that's the problem. It's not just the compiler; it's libc, like everything. So yeah, unfortunately that's like very sad because it means you're testing normally with all compilers.
Yeah, like, so every now and again, there will be upgrades, but they are usually put in a place, like in a moment where it doesn't matter for Python development. This is not a good time to do this sort of change because we're still just before a beta freeze and whatnot. So like, kind of not the best time to actually do this rollover, which is why when Ken Jin was doing his benchmarks, he needed to just use one version and couldn't easily compare the results that he was seeing with things that were on speedpython.org because that was a different version of a compiler.
He wrote a post called "I'm sorry for Python tail call interpreter result," which he explained the whole situation, and this is because do we have the name of the gentleman somewhere? Yeah, Nelson LH. Create basically a very excellent written post, basically investigating the whole deal. They tested with all versions of Clang, without. Like they made a fantastic investigation because obviously the results were very impressive, and something didn't click for him, for them. And then they basically investigated a lot, and the conclusion is what we're saying here. And Kenjin explain everything, and then the what's new also clarifies a bit the different. But I want to say something here publicly. Like there is nothing to apologize for. I mean, it's unfortunate that we did a benchmark and we saw like 30%, and then it was not like this. But like, I mean, this is not the fault of Kenjin. This is development, and there is no ill intent.
No,
here,
like
right?
it's literally how science is done, right? Like you use your best knowledge at the time, right? And now we know better, so you don't have to apologize that like you didn't know what you know in the future.
Exactly, and your metaphor is fantastic. Like this is also actually very good science because it's not the kind of science when you hack the p-values and someone finds out that you hack the p-values and then that's bad or whatever. Like, no, this is like you do some experiments and show some weird results, and someone comes in, like, put some research and says, like, okay, there is this extra variable that you were not taking into account, and that is good because, like, we are towards the pursuit of knowledge and truth, right?
Exactly.
And everybody is building on top of people, and like here, nobody had ill intent. Like, Kenjin obviously was not like trying to lie about this. They did very like clever benchmark, right? And they put a lot of effort, and like everybody, like this PR went through a lot of reviews, so it was not just Kenjin. Like everybody.
But most importantly, it is not being reverted. It is still like worth having. It is still a reasonable improvement. In fact, since this entire reveal of the Clang 19 bug, which is now being fixed in like the latest nightly of Clang, but Clang's 19 and 20 still have the bug. Like we actually got the version of the tail call interpreter for Windows.
Exactly.
So like, you know, okay, this is a supported change that has still a reasonable performance improvement.
And also, I prefer this other narrative, by the way. This actually made CPython faster.
Yes.
Much faster. The reason is the following. And actually, if you allow me to like twist a bit the message, I think we are actually making Python in some way with Clang 19 30% faster. The reason is the following. If you compile Python 19 without this bug fix, it was 30% slower. And then, because Kenjin's like work, we find out that there was a bug in Clang that otherwise wouldn't have been found until probably much later, because like, you know, this has been like there for a bunch of time until this was being looked at more closely. And then the bug was fixed because precisely this works. So I like the story because like it highlights how these actually have good effects rather than just the 3% that we are getting right now on top of the baseline when the bug is fixed, but also because we're getting the bug fixed on the compiler, right? So everybody wins.
Entirely correct. Plus, if you were hearing me saying like this, by the way, works on Windows, you probably remembered from previous episodes that somebody here on this podcast said that like, hey, but you know, the compilers on Windows are kind of weird because they don't support computed go-tos and whatnot.
Just they don't.
Yeah. Like that's Pablo who said that.
I did that. Yeah.
To make this tail call interpreter work for Windows, like that required adding support for Clang CL on Windows to build using computed go-tos. So that's a new thing that we also have now.
Thanks to Chris Abel. And then we have a change by someone called Morotis. This change actually apparently was here for a whole year, very classic of CPython. And this changes the default buffer size for io, the io module, to 128 kilobytes, and that landed. And that basically yields a 5x io performance on modern hardware because like the buffer is bigger. The same author previously basically made a change to buffer.Writer, like it's an object of the same module, and shutil, depending on how you pronounce it, copy file object for the same effect. So this person is basically obsessed with improving the I/O performance. Very good work actually. I have seen the work of this person firsthand.
Yeah, that's a good point because that's just, you know, change number. Things go faster, and there is a bunch of examples that this author lists on the issue that say like, oh, in this module we're actually doing something silly because you're reading byte by byte or something. So like, you know, like we might get like faster IO like in Python in general thanks to Morotti.
Right, very nice, very impressive. We also have, so Janchi basically moved the constant tuple folding to the control flow graph builder that basically substitute the old peephole optimizer that we have in the new compiler architecture, basically like re-architecturing the whole thing. Tiangao, which recently basically started to maintain PDB, and he has a lot of PDB improvements and has been working really hard on trying to adapt PDB to use sys monitoring, which was a much harder task than it looks like, because the challenge here was to make basically the whole thing backwards compatible, because PDB is building on a thing called BDB, and that thing is used by users, has a public interface and all things.
Yeah, and that was based on sys get trace set trace,
right, which is very slow because like it needs to like they have a lot of things per bytecode execution, very bad. And now it's using Mark Shannon's sys monitoring,
right,
and that makes the whole thing 40x times faster. Very impressive. Actually, the original patch that Tiangao has was actually faster than this, but making it backwards compatible make it slightly slower. But man, 40 times faster, like that's ridiculous.
Yes, like in many cases now having a debugger attached where you have some breakpoint, but you just say continue and you continue running your program, you will not notice a difference between this program running without a debugger and a debugger, which is amazing.
Exactly. Very interesting, the collaboration also on the PR. There is a lot of people chiming in, and people that do debuggers and build on top of BDB, so really cool. Talking about Mark Shannon, we have a big shift from the PyObject start pointer to now something called PyStackRef that is very annoying because it basically makes the GDB debugger a bit harder. But this is happening, and now we have tag pointers with embedded ref counts. Very cool. And this is only on the stack of the CEVAL, if I recall correctly, right?
Yeah, but like the tagged pointers, like with embedded ref counts, they allow you to also handle like immortal objects.
Very cool. Very cool. Okay, and then from Mark Shannon as well, we have the major refactor to basically all the headers, which is going to be very interesting to deal with. But yeah, this basically breaks dependency between the headers because the headers were already like a super nasty place. Like Victor Stinner actually put a lot of work on organizing this in the past into folders and whatnot. Mark Shannon did a lot of good work here to basically break these ties and organize it.
It's sort of like with gardening. You cannot just do it once and be done with it forever. The state of the headers was neat and tidy at some point, but due to the many changes that happened inside them, it ended up being a mess of interdependencies that Mark found to be frustrating to continue working with. Well, so he hunkered down and cleaned it up for 2025.
Right. Okay, now let's move to other cool stuff.
So the coolest stuff that I've seen recently was that there was a really obscure feature that Python had, and in fact, for most of Python's history, it was broken. So Serhii Storchaka fixed it, but then we learned that actually maybe you don't want to have this feature. That was the ability to change control flow in a finally block. So you could continue from a finally block, you could break from a finally block, you can return from a finally block. And that is very hard to reason about and caused a lot of bugs, including in the standard library. So Irit Catriel wrote PEP 765 alongside Alisa Coglan. And Irit implemented this PEP right now. So Python 3.14 is free from returns, breaks, and continues in finally blocks. And this, by the way, actually found bugs. We found actual bugs, yes.
A lot of bugs, actually, in the standard library. Mm-hmm. And that's very cool. Actually, the PEP that it made is fantastic. It also did a lot of studies on different libraries and what other libraries codes have bugs and all. It was outstanding. Very good work for Irit. I hope that we get her soon in the podcast.
We should. Okay. So Enzo Bonal made a change that introduced a buffersize argument to concurrent.futures.Executor. It has a map method, and now that accepts a buffersize argument. And this allows for a more space-efficient computation, which before it was literally O of n. So if you had an iterable that was huge, it was just unnecessarily using all of this memory. And it was just impossible to use it with designs with architectures that used infinite iterables. So now that is possible. It's again one of the changes that we're waiting for a long time to be introduced. So we're very happy to see it for 3.14.
Right. We have a change by Sebastian Ritau adding typing protocols for io called Reader and Writer that allow typing for more dynamically file-like objects. Very good for the typing folks.
What that actually does is we from the first days of PEP 4.8.4, we've had io, the kind of type for a file-like object in typing. But that was before protocols. So what that meant is this io was a very rigid type. So if you had actual files that were opened with the open built-in, that would work. But many people create file-like objects that are good enough to just, be passed around as if they were files, but they did not qualify for io of string or io of bytes for typing. So now reader and writer are much more sort of tight, meaning they're smaller. Their API surface is not that big. Reader and writer allow you to actually just substitute what you were using IO before, and that should work with more file-like objects for your particular use. So very cool to see it. And if you have any particular new file-like thing, you don't have to have any inheritance, right? Because with IO, that was just this old style nominal type. You had to create your new type that inherited from IO. Now you don't have to do any of that. Reader and writer are protocols. They implement structural typing.
Very cool. Right. It's like, who is Pabluco? I am Pabluco, apparently. It's today's episode.
Yes.
Okay, Pabluco.
Pabluco is Pabluco.
Pabluco, the one and only, myself. Man, I have like word flashes with this shit. So I made a change to linecache to be able to fetch interactive source code. This is actually a bug fix, it's not a feature. Although it's going to become a feature in the future once Tiangao does it. But the idea here is that we added this thing in Python 3.12 when you can like have like source for the REPL, right? So when you raise an exception in the REPL, then you get like nice source code there, which is kind of cool. For like the way this works is that we basically store the interactive source in linecache, and then we use that. Unfortunately, for when you run Python -c, that thing that code is called string in between like angle brackets in the when we call compile internally, and therefore if you use the inspect module of all things, which by the way Hypothesis was doing for something, I don't know, the whole thing is super complicated, and then it was some weird string that is not supposed to be there. But basically, like the way the inspect module was supposed to be working is that it was supposed to not find anything there and then fall back to the correct way to handle it. But now, because there is something there, it does some weird shit. Like, so basically it's telling that the lambda has some code or something. Like, really ugly. And fixing this was really hard. It's nasty shit, nasty. Like, because like we need to register code, and like we need to pseudo hash the object. So it's like it goes through C, goes through like really core files. Like the whole Python initialization is just really nasty for fixing something that like nobody is going to find except Hypothesis, but there is a lot of Hypothesis users. So
yeah.
But the idea is that Tiangao wanted to make this a bit more generic, so we did. So ideally, you can use this to register code for dynamic execution. So for instance, all the code, when you can generate a name tuple that is automatically generated code, or a data class, for instance. If there is code that raises inside your data class, normally you don't get anything because the source is gone. Like, there is no more source anymore, right? But with this code, you can register that code in linecache, and then you can get the code in the middle. So that's still cool. So Tiangao wants to do that in the future.
So Tiangao is going to do a lot, like PDB-P.
Well, we'll see if he does that.
Right?
Part,
like pretty sure when we actually add syntax highlighting to PyREPL, Tiangao is going to be like, hey, we need that stuff in PDB. Yeah. So like, yes, Tiangao is going to be a very busy person. Okay, and let's finish on Tomasz Pytel, who made ast.parse and unparse roundtrip better. So it turns out that if you had multiple statements between semicolons, unparse would only actually unparse the first one and just ignore all the others.
Right.
So now this is fixed. So yeah, like this is one of those things that was reported a long time back and ignored, and now there were duplicates of this issue. It comes back every now and again. So it's very cool to see it fixed finally.
And that's it. That ends being Pablo's spam episode about the new PEP, but I hope that you like the new super cool feature that you're going to get. This is the holy grail of a lot of things, and it shows how impossible things are not really impossible if you
don't know that they are impossible. Yes, exactly.
That's the only thing. But I knew that it was impossible, but then I forgot. Yes.
There is one thing that is impossible. It is impossible for us to produce a 60-minute episode. It's just not possible.
We really try, but we had so many things to talk about. I just want to say this PEP was co-authored by my two colleagues from work, Matt Wodnicki and Ivona Stobanovic. I hope I'm pronouncing it correctly. Very cool. So congratulations, first PEP for both of them. We hope to see them more in the future. And that's everything. Never a 60-minute episode. We lie all the time. But you know, like you like it. You like it. Everybody likes it. They say, oh, I love this like insane episodes that last for forever. I cannot wait to listen to your weird accent more time.
All right. So with that, next time we see each other, it's, well,
in 2 weeks.
it would probably be in 2 weeks, which would be before Alpha 7. But if we are honest, it might not actually be before Alpha 7, but it will be around Alpha 7. So maybe you're going to be...
Around.
Yes, maybe you're going to be actually celebrating the final Alpha
Wow.
of Python 3.14.
Very impressive.
A very colorful release.
Okay.
See you next time.
Until next time.